let's go over number 8. You guys ready? Okay, on number 8, this is a graph that was presented to you, I believe, on 1.2 at the beginning of the packet. But if you forgot, not a big deal. So the graph of this looks like the following. We have something on the 1, something on the -1. And there is an open circle on both of these because when you're dividing by 0, it's undefined. And the graph goes to the right and to the left. And the question is asking us, what is the value as x is approaching what number? What number are we approaching? 0 from the left. So here's from the right, here's from the left. It is approaching what y value? -1. That's it. Okay, now let's go to our last page on number 25. Is everyone good with this one? Okay. On number 25, we are looking at continuity. That I want to take out the card. Oops. And let's do a refresher, even though it was already on the video, in case you were not able to get to that one. So when proving continuity, we have to see, is it approaching from the left and the right, same number? And then, what about at that specific point? And does that point exist within the limit from step 1? So, let's go ahead and try this one. And let's write out, when something is on less than, it's going to be on the left. When something is greater than, it's going to be on the right. And again, if you're thinking, what about the equal to? That's going to be condition number 2, when it's equal to 2. So, is it continuous at x equals 2? We have 2 different equations, so I need to check from the left and the right. So limit. What number am I approaching on these? 2 from the left. From the left is my first function. So I have of the function. And then I want to plug it in and see what happens. 4 times the 2 minus the 1. And that's going to reach 7. And then I'm also going to write underneath it, if you have room, limit as x approaches 2 from the right side of the function. The right side is the bottom function. So I have 2 all squared plus a 3. That number is also reaching a common point of 7. So does the limit exist from the left and the right? So we know the limit in general as x approaches a 2 of the function. And when I say f of x, guys, you can always plug in the actual equation. I don't want to. Is equal to 7. So we're happy with that one. The second one says, what about the point? And the point is not the limit. It's simply f of 2. The point on this one is referring to this guy right here. So I want to plug in that number. So let's plug it in. We have 2 all squared, and I know right above it's got it. But to give you points, I want you to go ahead and plug it in. It is also 7. So that, since we have these 2 are matching, is it within the line basically? Yeah? So I'm going to go ahead and generalize. This guy matches this guy. Uh-huh.
Which one to do, top of the bottom equation?
Top of the bottom equation on step number 2? On step number 2, it is approaching exactly 2. This one is not including 2. The bottom one says greater than or equal to. It's including at 2. All right? So let's go ahead and summarize. We have, oh no, I'm supposed to write limit. So our limit as x approaches a 2 of the function is equivalent to the point. So therefore, f of x, and I'm going to copy the statement, because copying that statement is the easiest way, is continuous at x equals 2, and that is sufficient for a full credit.